Okay, hi everybody, Miss Brocker here. We've been working on volume so far this week. Today is day 4, and today we're going to put a little bit of those volume skills into some kind of real world problem practice. So, our learning target is up at the top of the screen. We will solve real world problems involving the volume of cubes and rectangular prisms. And we're going to start out with a word problem here. Good attack plan for a word problem is to read and reread the word problem. So that's what I'm going to start with. Ben's dad is building a sandbox. He wants to find how many cubic feet of sand he will need to fill the sandbox. The length of the sandbox is 6 feet, the width is 5 feet, and the height is 2 feet. How much sand will he need to fill the sandbox? So, what we're trying to find is the volume of the sandbox. He wants to fill it all the way up. So, usually, when we've been talking about volume this week, we've been talking about how many unit cubes fill up a shape or make up a shape. Now we're actually having a box that's a rectangular prism, the sandbox, and we're trying to find how much sand will fit in there in cubic feet. So I'm going to write on the bottom of the screen right here, I'm going to write volume. And we already know what units that's going to be in, so I'm going to write in here cubic feet. And I'm going to abbreviate feet with FT. Okay, now one other thing that I think helps me solve word problems is some kind of model or visualizing. And even though we've been working on volume for 3 days, this is still kind of a new skill. So what I'm going to do real quick on the side of the screen is kind of freehand draw a rectangular prism. I'm going to start doing that by drawing a rectangle and then make that rectangle 3-dimensional. And it's good enough. Okay, now I'm going to go ahead and label this with our dimensions. So the length is 6 feet. So I'm going to label right here 6 feet. The width is 5 feet. And then the height is 2 feet. Okay, how tall it is. I'm also going to write that over here. Length equals 6 feet. Width equals 5 feet. And height equals 2 feet. I think one of the challenges about doing these volume problems is staying organized with the information. Even though we know the order doesn't matter, when we do multiplication, we're going to end up multiplying all 3 of these numbers together. It's still a good idea to keep track of your work and stay organized. Okay, now I'm going to start by writing our volume formula we worked on the other day. Volume equals length times width times height. Again, we don't know the area of the base. We could find the area of the base, but I think this is our formula that we're going to stick with most of the time. If you really want to use volume equals area of the base times height, then you can use that too. I'm just going to stick with this one for most of today. Okay, now I'm going to fill in our dimensions, or our length, our width, and our height. And then I'm going to choose how to kind of attack this. I am going to do 5 times 2 first. It's 10. I'm done with that piece. I'm going to bring down everything I haven't worked on yet. 6 times 10 is 60. So the volume of the sandbox, or how many cubic feet would fill up the sandbox of sand, is 60 cubic feet. Okay, here's another word problem where we're going to practice our volume skills. Amar used 30 unit cubes to build a rectangular prism that was 5 cubes long, 3 cubes wide, and 2 cubes high. He took apart the prism and built another one with the same 30 cubes. What other dimensions, which remember is our length, our width, and our height, those 3 dimensions for 3-dimensional figures, could Amar have used? So, this is kind of an interesting problem. Now, we know that he is going to use 30 unit cubes, and that he's going to build rectangular prisms, or a rectangular prism that is 5 cubes long, 3 cubes wide, and 2 cubes high. Now, what our job is to find some other length, width, and height that would give Amar the same volume, or he could use the same 30 cubes to build. So we are not going to use 5, 3, and 2 for our length, our width, and our height. So let's kind of think about this backwards. We already know that our volume of Amar's prism is going to equal 30 cubic units. Now again, what we've usually been trying to find this week is volume. So this is kind of an interesting problem. We already know the volume of the rectangular prism, but we're going to work backwards to see if we can build another rectangular prism that has a volume of 30 cubic units. So let's use our volume formula to do this. We know that volume equals length times width times height. Okay, now I'm going to write a blank here. Volume equals blank times blank times blank. And we actually know, I'm going to write over the top of this, we actually know that our volume is 30. So what we're going to try and do is find a number and a number and a number that equal 30 when multiplied together. Okay? Now this is kind of a brain teaser. You don't want to pick like 30 times 1 times 0. That's not going to do us any good or make us a solid. So let's think. Well, we could use 5 times 3 times 2, but we don't want to use that. Our challenge is to use some other dimensions. So how about maybe, maybe we could use, 10 times 3 times 1. Maybe you could have a really tall, kind of skinny rectangular prism. Would that work? 10 times 3 is 30, times 1 equals 30. Yep, that works. Can we think about another one? Let's see. Okay, that got me thinking. I thought of another one we could probably use. I know that 15 times 2 equals 30, so we could make another rectangular prism that had a length of 15, a width of 1, and a height of 2. 15 times 2 is 30, times 1 is 30. Check, that works. Okay, and then another kind of similar prism. I'm going to think about other factors of 30 that I know. And this is a little bit different than what you're used to in 5th grade, thinking about 3 factors of a number. But we could do 5 as our length, 6 is our width, and 1 is our height. That would also give us a volume of 5 times 6 is 30, times 1 is still 30. So there's 3 different rectangular prisms with 3 different dimensions that Amar could use with his 30 unit cubes. Okay, here's another word problem to practice our learning target. The closet is 6 feet wide, 5 feet deep, and 8 feet tall. In the closet, there's a suitcase that is 2 feet wide, 3 feet long, and 4 feet tall. How much room is left in the closet? Okay, so what I'm going to do to kind of help us visualize this is I'm going to real quick try and sketch us a rectangular prism so that we can visualize our closet and our suitcase. And I know this isn't perfect, just real quick. Okay, now I kind of drew a really big rectangular prism. That black rectangular prism is going to represent our closet, and I'm actually going to label that with my black marker as well. I'm going to label that with our width of 6 feet, our depth or our length of 5 feet, and 8 feet tall, which is our height. So I'm going to write 8 here. Let's do 6 feet wide and 5 feet deep, or we can call that our length. Okay, now I'm going to try to real quick inside of there, with my blue pen, draw a smaller rectangular prism with these dimensions here. Okay, again, not perfect. I'm hoping it's enough that you can see that those are 2 rectangular prisms. And I'm going to label this one, kind of in the inside here, I'm going to do 4 feet tall. And let's do down here is our width, our wide, 2 feet wide. And I'm going to do my 3 right here. So I know this got a little bit messy, but I'm hoping it's enough where you can visualize that when the closet, the rectangular prism that makes up the closet, that volume is going to be a lot larger than the volume of the suitcase. Now, for us to solve this problem, what we need to figure out is how much room each one of these solids take up. And then that will help us find the difference or how much room is left in the closet. Okay. Now I'm going to write a closet here. Closet volume. And we're going to do the same thing down here for suitcase volume. Okay. Now we're going to work to find the volume of each one of those. So let's start with our closet volume. I am going to use my formula, volume equals length times width times height. And I'm just going to look at that and pull these out of here. So I'm going to use my height, my length, and my width. And I'm going to rewrite those. Volume equals 8 times 5 times 6. Now I am going to use, right here, I know that 5 times 8 is 40. Volume equals 40 times 6. And I know that 4 times 6 is 24. And 40 is 10 times more than 4. So our volume of our closet equals 240 cubic feet. Okay, now that doesn't mean we're done with our problem yet. Remember, we're going to try and find how much room is left in the closet, not counting the room that is taken up by the suitcase, so the volume of the suitcase. Okay, now we might run out of room here. I'm hoping this doesn't get too messy. Now for us to solve this, we need to use our volume of our closet and subtract the volume of our suitcase. Okay, so we know our closet volume is 240 cubic feet. I'm going to kind of draw a line right here to separate our work from our closet and our suitcase. Okay. Now next, we're going to find our volume of our suitcase. We're going to use our volume formula again. Remember, you're going to write it or type it every time that you do one of these problems, even in practice. And yes, I do expect you on a Google Doc to type this in. You are going to write volume equals length times width times height. And I'm going to circle this in green, our numbers here. Remember, they're the blue ones for our suitcase. 3, 4, and 2. Remember, the order of these does not matter with multiplication. I am going to do 3 times 4 first. 3 times 4 is 12. Volume equals 12 times 2. So volume of our suitcase, the amount of space that our suitcase takes up, or the number of cubic feet in our suitcase, is 24 cubic feet. Now for us to solve this, we're going to go ahead and subtract the volume of the suitcase from the volume of the larger closet. So I'm going to end up erasing some of this middle work quick. Okay, now to find the answer we're looking for, which is how much room is left in the closet, left over after we take away the volume of the suitcase, I am going to very quickly rewrite my closet volume feet cubed. I'm going to use that exponent. And from that, we are going to subtract our suitcase volume. Which was 24 cubic feet. And we are going to subtract, and we are going to get 216 cubic feet. As our answer. Okay, this is the last problem we're going to work on today to meet our learning target. This is one of those kind of puzzly problems where we know pieces, but we are also missing other pieces. So a prism has a volume of 360 cubic inches. The length of the prism is 3 inches, and the width is 4 inches. Find the height of the prism. So what we're going to try and do is work backwards using our volume formula, what we know about trying to find volume. So I'm going to start by writing that. Volume equals length times width times height. Okay, now this problem's a little bit strange. We know that our volume is equal to 360 cubic inches. Okay. And what we are trying to figure out is our missing dimension, which is our height. So we know that our length is equal to 3 inches and that our width is equal to 4 inches. And we are trying to find that final missing factor here, that if we multiply together 3 times 4, what is that number that we're going to multiply that product by to get to our volume, which is 360 cubic inches. So I'm going to start kind of by working backwards. I know that I can multiply my length and my width that I know. 3 times 4 gives me 12. And then what we're going to try and figure out is what is that missing factor here? I know that this 12, which I got from multiplying my width and my length, times our missing height measure is going to give us 360. Now think about what you know about multiples of 12. 12, 24, 36. Ooh. So if I know that 12 times 3 is equal to 36, I am going to use a number that is 10 times greater than 3 to get to 360, or to have 360 be my product. A number that is 10 times bigger than 3. Oh, 30. My height of my prism needs to be 30 inches in order for my volume to be 360 cubic inches. Our final answer is our height is equal to 30 inches. And if we kind of want to check this out, we could work backwards. I'm going to use a different marker color to help me with this, help this stand out. And I can use my volume formula to check my work. So volume equals length times width times height. If I plug in my missing height value I found of 30 inches, we should get our volume, we knew, or sorry, I should circle this one here, of 360 cubic inches. So I'm going to rewrite that with my units in. So 3 times 4 times 30. 3 times 4 is 12 times 30. I know that 12 times 3 is 36. So 12 times 30 has to be 10 times greater than 36. 360 cubic inches. Oh, works. We're right. Also, when you guys work on your practice today, I know some of the problems are going to be challenging, but if you keep working backwards or keep thinking about all the knowledge you have about finding volume, you should be able to kind of figure out those puzzle pieces or those missing pieces. Also, make sure that you are doing something to check your work, just like this example that we have circled here in red.